This is fundamental problem 11 from chapter 13. If the 10-kilogram ball has a velocity of 3 meters per second when it is at the position A along the vertical path, determine the tension in the cord and the increase in the speed of the ball at this position. So we have the radius of curvature, which is the same as the radius of the circle, which is 2 meters. We have the angle here. We have the speed at this point. And they say it's a vertical path because if you just look at this picture, it could be that the ball is spinning in the horizontal plane. You can't tell from looking at the picture, so they tell you it's a vertical path, so you know it's spinning in the vertical plane, and this point is higher than this point on the circle. Okay, so now what we want to do to begin with is to determine what the tangential direction is and what the normal direction is, and possibly the binormal direction. So the object is moving in the tangential direction, so you can see the velocity vector is pointing this way. So this is the tangential direction. Normal always points in towards the center of the circle. After we have figured out the normal direction and the tangential direction, we can go ahead and draw the free body diagram. So this is the tangential direction, and this is the normal direction. Because it is going in a vertical path, gravity is pointing downward like this. And then we have to ask ourselves, what else is touching the object, or what is touching the object? So the cord is touching the object, and the cord exerts a force, which we will call T for tension. We want to find tension and the increase in the speed. Remember, V dot tells you how the speed is changing. So we want to find the increase in the speed, which is V dot. So now, after we find the forces, we take a look at our equations. So I have a force pointing in the normal direction and a force with components in the normal and tangential direction. So I'm going to be using the sum of the forces in the tangential direction is equal to the mass times the acceleration in the tangential direction, and the sum of the forces in the normal direction is equal to the mass times the acceleration in the normal direction. Then I go back to equation 1218, and I see that the tangential component of the acceleration is v dot, so this is m times v dot, and the normal component of the acceleration is v squared over rho. So before I can apply these equations, I have to break the force of gravity down into components. Conveniently, this angle is 45 degrees, which means that angle must also be 45 degrees. And since sine of 45 degrees is equal to cosine of 45 degrees, it does not matter which angle you use. So let me draw the free body diagram again. So I have T, and then because I said this was 45 degrees, this angle would be this component would be mg cosine of 45 degrees, and this one would be mg sine of 45 degrees. But they are equal to each other. Okay, so now if I look in the tangential direction, I have one force acting in the positive tangential direction. So this says mg cosine of 45 degrees is equal to m times v dot, and the mass cancels out. Look at that, we already found v dot. You just have to plug in g. And then inwards is the positive normal direction, so I have t minus mg sine of 45 degrees is equal to m times v squared over rho. I was given the mass, I was given v, no, rho is 2 meters. I just have to bring this over to the other side and plug things in, and I have t is equal to mv squared over rho plus mg sine of 45 degrees. I will let you plug in the numbers on your own. You should find that t is equal to 114 newtons, and v dot is equal to 6.94 meters per second squared.